So I have to plug what in here? That. Here is the what? That. And then what's here? That.
That.
Isn't this a brilliant idea? We'll keep going. What's our goal though, Amber? Where are we going? We want this column to turn into what number?
0.
Zero. We'll keep going. But the idea, this is a programming game. This is for programming. So you can program it, let a computer do all this. That's what your calculators are doing. I can't guarantee it's Newton's method. I don't work for TI. But this process, do this about 6 or 7 steps, you're going to have it accurate about at least probably 7, 8 digits. Isn't that cool? Now you have an understanding like, what was it, magic? How is this calculator doing this? It's, people use calculus, right? Calculus is being used to solve equations. Isn't that cool? I think this is one of the neatest things. Great idea. You know, rather than just like, let me guess 2 numbers and let me take the average of them or something, like a midpoint method. This is neat how he slams tangent lines and uses those as your next guess. Tangent line, next guess. Because immediately, it's like, it moves quick, doesn't it? Zoom, psh, zoom, psh, zoom, and you're there. Isn't that cool? That's how it works. Now, if you guess something really far away, okay, it'll still get there because it'll be like, zoom, psh, zoom, psh, zoom, psh, zoom, 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 it'll get it. Hey, what do y'all get here?
Is a big number, 0.
It's gonna be long, I knew it, Kayla. All right, what is it?
0.6860
686.
46511. We can, after the 0, you can omit that, right? Because 6
right.
8.
That's right. Is that right?
Yeah.
There's a 6 after that 1 at the very end.
There's 116.
Thank you so much. Hey, if you're curious about a test, you go, how far do you have me go out with this thing? I just have you go out 2 iterations like this. Everyone want me to put that table on there? I will gladly do that. Who wants it? I'll gladly give you the table. I provide it, even for online classes, I provide that table. A lot of them don't use it though. They like, oh, I'll memorize the formula out of the book. But that's really what it is. Anybody here ever use Microsoft Excel? That's the idea, like, if you just program this Microsoft, it's kind of fun to watch. So this is what, all you who know Excel, I encourage you to just try it on a couple problems at home. And just try it, it's fun. Just, you know, you write in the codes, like, you know, when you write, you call this like cell A1, and this is what, cell B1, and you're like, if that's A1, and that's B1, and this is C1, you could say it would be negative what? Negative equals negative B1 divided by C1 plus A1, right?
Mm-hmm.
You put that in there and let the thing just keep running and just copy and paste a bunch of cells. It's kind of fun. But I'd only have you go out 2 iterations, yeah.
So on the test, you would just give us this table?
That's right, I would give you this table, X, Y, I would give you that formula. Heck, I know you could figure out the derivative, I might even write the derivative there anyway, right? Now, if anybody wanted to see, I did do this in Microsoft Excel. It took less than 60 seconds. Would you flip over? That's less than 60 seconds in Microsoft Excel. Did you see it, Josephine? I mean, it was just, now if anybody wants me to sue it, I'll do it up there. But it's more like, I know, if you're like, yeah, can I see that? I'll be glad to do it. Do you want me to?
No, it's cool.
You sure?
Mm-hmm.
Okay, yeah, but that's all, it takes less than 60 seconds. It's like, have you used Excel before?
Yeah, it's very like.
It's not hard.
It rounds up everything.
Yeah, and all I do is I would say like, I called it like, say that's cell A1 and B1 and C1. My formula, I type into the Microsoft, I go, this cell will always equal negative B1 divided by C1 plus A1, right? And I hit enter, and it takes the number, and then I copy and paste those cells into what? A bunch below.
And it rounds up like everything.
That's right, and it nice and neat, everyone went out to 6, you know.
So, would we?
And what happens to column Y? It goes down to zeros, right?
Would we start doing the magic when get y equal to 0?
What's that? That's right. That's your goal. You go, when does it stop? And so the math programmer or the computer program, when they write the program, they're saying once they achieve what? About 8 zeros in a row, stop the process. Does that make sense?
It has to be 8 zeros in a row?
Could be 8, could be more accurate. Might be more accurate, you know? Now you're getting into coding language, which
Oh.
I used to be familiar with, but now they've made some what? Some neat upgrades and stuff. Things used to be accurate to like 7, you know, they call it single precision or double precision. Any programmers in here? But things in like single precision and double precision you can be accurate to 15 decimal places. You can take Excel and make it in double precision. You have it accurate to 15 decimal places. So it would depend on the what? The actual calculator
Yeah.
and tool. And here's another thing. You go, am I absolutely certain this calculator runs through Newton's method? It may, but I've asked people. They said, people have invented other techniques to solve equations. It might run through another program, like some kind of technique, but this one's quick, isn't it?
Mhm.
It's like instant, it's like zzz. So, hey, did you want to try another one where the table would be given to you? All right, let's try one. All we're gonna do is run at how many iterations? 2? Does that sound good? All right.
The equation will be given, right?
You bet. Equation will be given, the table will be given, even this would be given. I'm not here to make you memorize that. Because think about it. Are you going to be doing like Newton's method all the time? No, but
No.
keep in mind, there are Calc 2 teachers out there who expect students to like answer a question when they go, when you say, how could you solve something like that? When you go, well, x cubed plus x minus 1, you go, how could you solve that mathematically? Well, quadratic formula is not going to work, right? I mean, outside of saying, I'll hit it on my calculator, you could say, you could use Newton's method. They like when you say that. They like that you know that Newton's method is a technique that can solve not only this equation, but what? Any equation, multiple equations. It could have a sign in it, cosine x, right? Natural log of x.
So would you always want those numbers written as decimals?
You don't have to. I'll say that. If you prefer fractions, please feel free to fract this. I'm serious, I will check it.
Are you gonna get?
Because I've seen that previously. I have students who like to write those as fractions. Now you might be like, good golly, these people are good at fractions. Some people are good at fractions, and they use what button?
The
The frac button. They use the frac button. So, hey, Josephine or anybody in here, you want to write these numbers as fractions? I know, like, when I make my answer key, I usually put decimals, but I'll quickly go check the frac on it. I'll frac it to see what it is. Absolutely. All right, let's make something up. We won't make it too crazy. All right. Ready? Now, let me wipe this out. How many iterations do you have to do?
2 we said, right?
2. Now when everyone's gonna be silent for probably a couple minutes, you know why? Because there's gonna be a bunch of calculators, right? They're gonna be typing out numbers and stuff. So just give everyone time to do this stuff. Don't get upset if one of your decimals is off. Sometimes you can easily make a little error in these things. But keep in mind, this would be given to you, right? Let me get all this out of here. Now, Ewan, I would even provide the first guess for you. That sound good? But is that the solution? So look, what do you gotta fill out? You gotta fill out how many boxes? I want you to do 2 full iterations from it. If you wanna have fun, go back home and do it. Well, what's my first guess? 1. Now I'm gonna go to Amber. Amber, what's this equation?
What equation are you using now?
Yep, x cubed plus 4x minus 2. Hey, did anybody look at the graph already? If you're curious, it goes like this. Now, give it a shot. Does anybody know what this would be?
Yeah, sure, that's.
Oh, Jess, what would it be?
3x squared plus 4.
Love it, very good. So you might want to write that down, right? Put that for the M. But I'm giving you the guess, Jess.
Is your first row's always 1, or does it depend where you're graphed?
It depends, and I want to be honest, like, I will provide the guess for you, but that was a good question. It isn't always one because, but have you ever used the solver before? Yeah.
Yeah.
And you and I have always done like, we push an arrow or we hit left bound, we make, like she said, a guess. That's what we're doing. We're giving the calculator we had. That's the only way it could run through a program like this. You gotta give it the guess. And that's what we're doing when it goes, what's your left bound? You know? Have you ever used the intersect thing when we did the intersect? And enter, 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 and all that stuff? Those guesses is making it do something like this. But when you and I, wherever we put that what? When we hit enter and that cursor is, that's what's going on.
So Professor,
Yes.
now over here the x-intercept is like negative 1.333. So you want us to use the bar, right? On
That's
that.
right.
Okay.
This doesn't have Excel.
So would that be okay, like when you're doing a point method, decimal, as soon as we encounter the first decimal, we can omit the rest of the stuffs? This is a big number.
Yeah,
Like-
that's fine.
That's fine.
Yeah. Keep working, I'm gonna do it the fun way. Alright, this will be X, this will be what, Y? What will this column be? M? And what will this column be? X int. Now, what's my guess?
1.
1. Now, what would I have to put here if I did this in Excel? I'd have to put the equation of what?
The
Y.
Y,
So what do I have to type in?
x cubed plus 4x minus 2.
Good, so I have to type this in. But remember, X is what cell?
Oof, A.
A1.
A1.
Is it A1 or A2?
A1.
A2. It's looking at A2. So I'm going to write equals, ready? Equals A2 cubed plus 4 times, so let me do it. Equals, you always start with equals, everybody's never done this before, right? Equals A2 raised to the what?
Cube.
Third, plus 4 times A2, and then what?
Minus 2.
Minus 2. I'll hit enter. Cool, now I need a formula for M. What is it?
3x squared plus 4.
So I'm going to have to set equals, or we start with equals, equals 3 times which cell squared?
A2.
A2 squared plus 4, hit enter.
Uh-huh.
And then this will be a fun one. What do I put for this cell? Now remember, look, here's Y, here's M, and here's X.
So B2
All right,
negative
equals negative
B2
B2
over C2
over C2
plus A2.
plus A2. Someone agree?
uh-huh.
Someone agree with this? You see that, Jess? Feel free
It's
to-
not gonna like put it in a seat B over all of that?
That's right, isn't that cool? It'll totally do it, it'll equal negative B2 divided by C2 plus whatever A2 is. And I'll hit enter. That's the only code I have to do. Now what can I do? I can say, which cell should this always equal? This will be the next guess. This should always equal which
The
one?
first cell.
Equals cell D what?
2.
Equals D2. And then I can just highlight this, and you all know this, copy, right? Copy cells, there's the copy. Go here and hit paste. What's paste? Control V?
Control V, yep.
Paste it. And then take all this, copy, and what?
Paste.
Paste. Here's the fun way. And when I know what the answer is, I don't have a graphing calculator. The answer is x equal to 0.473466, right? Because Belraz, eventually what came up? Zeros, right?
Zeros.
Look, this was at 0.00000001, right? You can see this is even more accurate to 11 places. Does that make sense? Now, I wanted you to check your answer. Did you get through 2 iterations? Want me to enlarge that? Let me zoom in. Zoom, zoom. What? Get up there. I wouldn't want me to zoom some more. Zoom, 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 zoom. How'd y'all do? Did you get it? 2 iterations? Did you get to that one? Did you get to the 0.47658?
I didn't round off at the 8. The first Y is 3.
Did it work?
How do you get to
Oh, the 3? To get this, you always have to plug this into what? That. So what's 1 cubed plus 4 times 1 minus 2? 3, right? And then what's this? 3 times 1 squared? Oh, you didn't fill it out yet? Oh, 7. And then you do the x in